Hello and welcome to Nodes 2020. I am Michael Black. I am a Neo4j Ninja. A Ninja is a community member like yourself who is a certified developer and is giving back to the community. By giving back to the community, ninjas receive exclusive perks and training. Your training doesn't have to stop after you've completed your certification. You can become a Neo4j Ninja too. Visit community.neo4j.com. Introducing our next presenters, Vladimir Bakvansky, Principal Architect at PayPal, and Deepak Chandramouli, Principal Architect at PayPal. They will be talking about mastering enterprise metadata with Neo4j. To give a little background on our presenters, Dr. Vladimir Bakvansky is a Principal Architect with Strategic Architecture at PayPal. He is the lead architect for privacy and developer experience. Before joining PayPal, Vladimir was the CTO and founder of a custom development and consulting firm. He is the author of the popular O'Reilly's course, Introduction to Big Data, and co-author of the O'Reilly course on Kafka. Vladimir received a PhD in computer science from Aachen University of Technology in Germany. I hand it off to you, Vladimir and Deepak.
Hello, welcome to our talk on Graph of Enterprise Metadata powered by Neo4j and Spark. My name is Vladimir Bekvansky, and I'm joined here with Deepak. And a few words about us. I'm Principal Architect with Strategic Architecture at PayPal, get involved in a variety of projects around the data platforms, privacy, developer experience, and introduction of various new and advanced technologies in the company. Deepak?
Thank you, Vladimir. Hi, everyone. This is Deepak. I'm very excited to be here today. And thank you all for making the time to listen to us and converse more about this concept of graph of enterprise metadata. About myself, I'm a tech lead for a couple of critical data products in PayPal. One is Gimel, which is a big data framework which we open sourced. It's based on Apache Spark. The other one is Unified Data Catalog, which is PayPal's enterprise data catalog, solving a lot of governance, privacy, regulation, and other problems that we have at scale. So we'll be touching on a few aspects of Gimel and Unified Data Catalog in our talk today. Over to you, Vladimir.
All right, thank you. So we will give you a brief introduction of where we are and how did we come to this work. So last year, we were working on our Unified Data Catalog. And this Unified Data Catalog collects the information about a variety of data sources that we have. As you can imagine, in a large company, there is quite a bit of this metadata around a variety of stores. And we decided that we are going to collect this information, and we realized it would be useful to show it as a form of graph. And that would include the various data stores, the tables, the columns, but also it can also include what kind of information is stored there, who is responsible for it, and so on. And as we embarked on that, we created our tool that was providing recommendations for people based on the context of their work and involvement with various data sets. We recognized we could do even better if we broaden the scope of things that we are bringing in and try to combine that for more meaningful insights. So let's see what is the graph of enterprise metadata. So here you see a typical landscape of the enterprise architecture. At the bottom, you have a foundation, which are the data centers. That can be your own data centers, or you can be using the cloud. On top of that, there is a variety of data sources. And they will include traditional things like relational databases in different flavors. It will also include a variety of big data systems, your typical Hadoop and Spark-based ecosystems. There is also a variety of offerings in the cloud from Google and Amazon, but also there are some additional stores, for example, Kafka for streaming data and Elasticsearch for certain search applications. All of these data is protected using a variety of security and identity and control mechanisms. And there are fairly rich definitions around those. And the people who are involved in the operations with data belong to different organizations. They are in relationships with other people, and they collaborate with a number of people on the team. And as they do their work, they create a variety of artifacts that you can see here in the middle. And that will include code that is in GitHub, and you have a variety of tickets in Jira and the documents in Confluence. And then finally, all the way on the right-hand side, there are a variety of applications and processes from APIs with rich definitions of the operations and requests and responses. There is a SQL in applications that is modifying the data, variety of ETL applications and pipelines, and also the big data ecosystem for both batch and streaming applications. To make this even more interesting, here we are talking not only about the PayPal as the core, but as the company acquired a number of other entities over time. Here on the left-hand side, you can see our, we call them adjacencies, companies like Venmo, Hyperwallet, Zoom, and so on, which are all part of the PayPal family, but they started with different organization and different technologies, and they add complexity to our ecosystem. So looking at the data that we have, you can start with the data that belongs to an organization, but you can then look what is the metadata available for it. So there is data that belongs to the organization. There is a certain set of business-oriented metadata, technological metadata for the infrastructure that is running this, a variety of data classifications. And this point is becoming increasingly important. Privacy regulations, financial regulations, healthcare data are all highly sensitive, and you want to know exactly which part of your data belongs to different classification according to these dimensions. When you start combining these things, you can recognize that this would be very useful for governance. And the governance is able to give you good insights into privacy, compliance, and regulations. And just to illustrate this, for privacy regulations like GDPR, the customers have right to ask, I want all of my data to be deleted. The question is, what are all the systems in which the private person's data reside? And enabling such insights by looking into the graph of data, connectedness kinds of data, is something that dramatically improves the posture of the organization when it comes to compliance to these regulations. And also, it gives you an opportunity to transform something that is often perceived as a burden, compliance to regulations, to becoming a competitive advantage. So we had this idea of the data model that is combining a variety of enterprise metadata, and looking into how would that look like in our Neo4j database would enable us to traverse the relationships, explore the entities, see what are the connections, and possibly run a variety of algorithms to analyze the relationships, find the connections. And the beauty of the graph model for that is its flexibility. So we can bring in the data that comes in a variety of formats, has a variety of attributes that can even change over time, and we can start establishing relationships, and we can grow these relationships dynamically and explore them. With this, I will have Deepak show you about the system.
Thank you, Vladimir. Thanks for setting the context. And it's great to have this idea and also have a great perspective of how we can connect the metadata. But ideas require us to start with something small in the form of a proof of concept and then mature it to production grade. And that is what we are going to see in the upcoming steps. We have started with a small sandbox code and a demo. Basically, it's a proof of concept. And this is also out in the GitHub. We have prepared a playground for everybody to experience this firsthand. After this talk, you can go to the graph of metadata code base and bootstrap the Neo4j Docker and start a GraphQL interface and play around with it. Also, if we would like this to not end with this talk, rather we want to build on top of this. We want to build a community of ideas and expand on this. So we have started a Gitter where we can continue to collaborate after this conference. So let me quickly go through the end product of this code base, which is actual graph, and also give you some idea how it works alongside the GraphQL interface. So once you bootstrap the GitHub repository and start the Neo4j Docker container and also start the GraphQL interface, there is also a nice set of data sets that we prepared that will help you build this graph and play along with it. So once you run those cipher codes, you would be able to see all these nodes and relationships created. And this is going to be a physical representation of the concept that Vladimir talked about. You can see there is this notion of enterprise. Let me take a concrete example of PayPal Inc., which has so many different subgraphs to it. You start connecting all these dots together. There are users who are nothing but employees in an organization. There is data technology landscape. There is security aspects to it. There's metadata in the form of code base, logs, processes. There is the notion of adjacencies or the PayPal family, which is all these different companies that we have acquired and are now part of the bigger ecosystem. Then there is access controls and policies. Typically, companies have identity access management as the single source of enforcing policies, but there are also other ways like Apache Ranger and so on. So these roles translate to so many different access policies, and these policies again have a lot of users associated to them. There is the notion of role owners, subscribers, and all of that. And as you look at users, the users themselves are core part of the organization, be it product development or any other life cycle. When we talk about metadata, we should also connect in the form of users, the location, the organization, the geography, and so on. That's one other aspect. And when we talk about security, there could be the notion of different security zones, which have different systems in them. So all of these aspects are what we are connecting and forming as the graph of enterprise metadata. Now, coming back to what happens when you expose this metadata, right? When you build the metadata, you need to have a nice interface so that not only algorithms and also the likes of Python libraries, Java libraries, or Spark libraries can interface with the graph, but also we should have a unified semantic layer to expose the data to the likes of low latency systems such as front-end applications. This is where GraphQL comes into play. We have the first cut of GraphQL schemas created here, which will help us connect to the graph. As you have seen all the data sets that are being created there, you can play around with the graph to get the response. This basically provides a facade in the form of a semantic layer for mobile applications, front-end applications to interface with the graph. Again, going back to the GitHub repository, there are steps to bootstrap Neo4j GraphQL, and also we have laid out certain data sets and schema. The API code base should take you to starting a small node application, and there are data sets which were actually bootstrapped in the form of graph, and we have a nice set of code base that can help you load the data quickly and also create nodes and relationships once the data is loaded. The end product being this graph of enterprise metadata, which is conceptual, but also it represents a true form that would exist in an enterprise. Now, this is a very nice proof of concept, but how do you scale this for an enterprise? This is where we need to start thinking about longevity of such a graph building process, where architecture and data flow is very important. As I said, there are multiple places where technical catalog can exist. In PayPal, we've solved this in the form of unified data catalog, which aggregates all this technical metadata into a single place. It gives us a nice view and perspective of what kind of data stores we have in the ecosystem, technologies that we have in the ecosystem, databases, tables, objects, and all of those. And we have various scanning systems in the form of enterprise data scanners and classifiers. Even in the notion of cloud, we have, for example, Google has the concept of DLP, which scans the data and classifies the data, be it is in Google Cloud Storage or big table, big data in any other form. And we have the organization data that is going into our backend systems. For example, we may have a system like Workday, which could be used to form all the policies and flows around org structures and people and process. And that is again persisted in the backend system. And identity access management, it's a huge area by itself, given the amount of time and energy any company invests in security. So we have all these access controls owners, the users of these access controls, who are all nicely persisted in some form of metastore in the backend system. Artifacts and code bases live in GitHub. Wiki and Jira go into document-based stores. And operational metadata, which is the most complex part of an ecosystem, goes into various places in the form of logs, in the form of API call logs, or even indexes which have log stashes. So that forms a completely complex ecosystem of logs and data mining capabilities by themselves. Finally, one thing that we usually not pay attention to is social metadata that is internal to the company. When I use the term social metadata, we talk about Slack chats, Slack channels, a lot of Teams conversations. Most often, the code base and Jira or Wiki gives us a very well documented, structured form of metadata, but a lot of knowledge is actually floating around in the form of tribal knowledge among people. And people exchange ideas most likely in the form of conversations or Slack conversations or team conversations. So we do see an emerging pattern where we have a lot of applications that are doing Slack bots, crawling the Slack threads and Slack channels, and trying to answer questions via Slack bots. But why not tap into that metadata and also connect them with our larger graph of enterprise metadata is the question. So that brings the social metadata also as an important component in building the graph of enterprise metadata. So we've seen a lot of different source system of records and applications that are part of the core platform in any organization. But all of these applications persist data in various different forms. Operational data may go into Oracle, MySQL, or another relational store. Document data can go into Elasticsearch, HBase, or MongoDB, or any other form of Elastic search capability. And we have all these logs going into various message buffers like Kafka. And there are also APIs that are now being treated as data ecosystem. So how do we tap into all of this and then unify them? That brings us a big challenge in terms of scale, complexity, and also longevity. This is where we are looking at a few core components of building the graph. One of them is Spark. Apache Spark gives us this nice way of performing distributed data processing. And it also offers us a facade in the form of Neo4j connector, where you can transform a data frame in Apache Spark to a graphics. And then from there, we can basically convert to Neo4j graphs in the form of nodes and relationships. While on the sourcing side, we are tapping into Gimel, which is our own product, homegrown product. Gimel's core capability is to abstract data access. Regardless of which type of source an application is working with, when it's coming to big data, Gimel should be able to tap into that with a unified API so that the problem of working with multiple sources is solved by Gimel, while the application can focus on business logic. Now, when we put these two together, we are nicely forming a batch processing system that can work at a higher latency. But we also would like to go into a future state where there is this concept of near real-time graph building. That is where Apache Kafka and Kafka streams should come into play, especially with the emergence of solid support for Kafka streams with Neo4j. We see that as also complementary capability where we have this nice Lambda architecture with Gimel and Spark doing the batch processing and eventual consistency, while Kafka streams plus Neo4j giving us this capability to have a near real-time graph building. To summarize, distributed processing via Spark, access simplification via Gimel, and near real-time graph building via Kafka. But once we've solved, or once we have a idea to solve this problem, the next one is how do you make a good semantic layer where all applications alike can tap into the graph. This is where we are seeing GraphQL and Spring coming into play, with Spring providing us the capability to scale and also having good connectors for Neo4j and other sources. GraphQL should provide us the facade for exposing to multifaceted front-end clients like mobile, web, and so on. To summarize, we are looking at 4 different aspects. One is multiple sources. How do we source the data from various different system of records? This is where we see the combination of Gimel and Spark, providing us the ability to access data in a simplified manner. And in terms of processing the data at scale, we are looking at Spark and graphics, which will give us a nice segue to processing the data and converting them into nodes and relationship. And Kafka streams in the future should give us the capability to have a near real-time CDC on the graph. When I say CDC, I'm talking about the change data capture capability to update graphs as early as possible when data is in the source. We have talked a lot about how to source data, but once we get them in the form of this deeply interconnected graph, we will need to tap into a lot of super rich features that Neo4j offers. So a couple of them is when we want to look at community detection or centrality, or even look at other capabilities of ML, we will be tapping into the graph algorithms and then other kind of epochs that are available in Neo4j. And we are looking at exposing these as GraphQL schema so that not only Python, Java, or Scala or Spark libraries can tap into this, but also front-end APIs can really leverage the power of Neo4j in a very meaningful way in the form of semantic layer. I talked about Gimel and how it abstracts. I just want to give a few concrete examples how Gimel solves the problem for us. If you ask the question, why do we need to go for Spark and Gimel while it seems like a smaller scale problem? Let me give you a perspective of the growth that we are seeing or the scale at which any enterprise would operate. In terms of technical metadata, we have over 7 million data sets that we have cataloged, and it's just a work in progress. That means we have 7 millions of data assets and millions and millions of fields and a lot of classification of the elements that we are going to have as we scan these data assets. And now if you connect the operational metadata, the hundreds of thousands of data applications that run every day, creating all these logs that go into different places like Kafka, Elasticsearch, Splunk. We are looking at terabytes of metadata that we need to crawl, process, and then finally connect their dots. Security and identity aspects are usually not well talked about, but when we go look into it, there is a lot of depth and connection between the notion of access controls, policies, users who have access to these access controls, and the owners of these access controls. And it's a depth of information that we will need to process at scale to connect them back into our technical metadata. And the most complex and the challenging part is artifacts in the form of code, logs, creating lineage, and also tapping into the social data, where we'll be tapping into all of these not very well structured data assets, which are exposed in the form of APIs or in the form of logs. So when we put all these things together, we are looking at metadata itself as a big data processing problem. That is why the scale of Apache Spark and the access simplification of Gimel comes into play in the form of architecture and data pipeline capabilities. So here's an example of how we can use Neo4j connector and Gimel connector to connect the dots by processing data in Apache Spark. The first snippet should give us an idea of how to start a Spark application with Gimel and Neo4j connectors. And this is the unified data API that we call in Gimel. Here is a Scala Spark snippet code. We are initiating a data set, which is the unified API. And we will be seeing soon how this data set can be used to read and write data. And most of you might be familiar if you've been using Neo4j. There is a Neo4j connector for Spark. We add the library and start a connectivity to the Neo4j instance. Here is a concrete example of how data can be accessed via Gimel when it is in Kafka. Kafka is a message buffer. Data is ephemeral and data flows in various formats. If you think about various formats such as protobuf, Avro, JSON, or text, and then start combining that with the perspective of how Kafka handles data in the form of brokers, topics, and partitions, it's pretty complex. And when we take a data engineer or an ML engineer or analyst who's trying to work with Kafka for one of their use cases, it becomes a really challenging learning curve for them to know what is Kafka, how to access the data, and then finally deploy an application that works at scale. This is where Gimel comes into the play. Gimel offers a unified config and then a unified data API. The unified config is what enables the right connectors that exist in the Gimel libraries to start working with the sources or the targets, while the unified data API is what the user, when I say user, a developer, would be using to read and write data from various stores. As you can see here at the unified connector config, it provides you a way to define where is the data, what is the format of the data, how do you consume or write data into that particular source or sink. And at the bottom, if you follow, the unified data API provides a single line of code to read data and then presents a single format of data to the user or the application, that is data frame. With that, the user now really has to work with solving the business logic or the problem rather than worrying about how to access data from be it Kafka or Elasticsearch or any other store that he or she may be working with. Now, Gimel also offers the form of catalog. If you see the line here, there is the catalog provider notion, where the catalog can be provided at runtime, or it can exist in a Hive table, or it could also come from something like a unified data catalog in PayPal or an external catalog in any other enterprise. Expanding on the same theme, Gimel also works with relational databases, be it MySQL, Oracle, Hive, Teradata, it doesn't matter. You just pass the config and use the same API to read and write. And we put a nice facade on top of this in the form of SQL layer so that you could also write a code along the lines of select start from Kafka, insert into Elasticsearch, start streaming it. All of this are very specific to Gimel, and I would probably defer that for a separate discussion. But if you go to gimel.io, it would take you to all the documentation and support that Gimel has. Now, coming back to the area that we are focusing, once we have solved the problem of accessing data, and we are familiar with data processing in Spark, how do we persist this data meaningfully in Neo4j? This is where the Neo4j connector for Spark comes in. Here, we are able to transform the graph from Spark's graphics into Neo4j nodes and relationships. This is an example of how you could do that. And there are code snippets that we will be adding to our Gem GitHub repo, which you can refer in the future. So the next part of our data flow or the architecture is, once we build this graph, how do we expose the graph to our applications and end users? There is always the notion of Cypher, which is the core component of working with graph. You could write a Cypher query on a Neo4j console, explore that, and then once you have the Cypher ready, you can use that in different ways. You could write a Java code, a Python code, Scala code, or any other library that Neo4j supports. But that's a batch application. That's a high latency processing. But we could also use GraphQL, which is more emerging in the last 1 year, and expose this type of schema so that low latency systems, which are front-end applications, can tap into Neo4j via APIs. This also gives us a nice way of presenting a semantic layer. When I say semantic layer, more of a business defined layer, plus all the capabilities that GraphQL offers in terms of making sure somebody is not oversubscribed or undersubscribed to data. So to get the data set, when I say data set, a table and the descriptions of the data set in the form of columns and whatnot, one could write a Cypher query, or by defining a GraphQL and exposing that as an API, it translates to a GraphQL query which can be plugged into any kind of front-end system, which is what we will get out as a response. Here you can see we're talking about a table that exists in a database and all the columns being exposed from there. So with this being said, we have now formed a nice view of how we can read data from sources, process them at scale, form the graphs, and then expose them to our end applications, be it in the form of big data or data processing, ML, AI, or even in the form of front-end applications like mobile and web services. I would like to transition over to Vladimir, who will help us see what is the next step and where we are heading. Over to you, Vladimir.
Very good. Thank you, Deepak. So here we are exploring our graph of enterprise metadata. Oh, we have a couple of realizations. One thing is that we looked into different parts and we realized that by combining this, linking them together and exploring them, we actually get more value and more than this is just the sum of the elements. Another interesting lesson is around the data awareness. In every enterprise, there is a data hiding in various places. We want to understand what it is. We want to understand it, particularly how can we connect it with other data in order to generate some insights. The third thing is graphs are everywhere. When you look at the different ways how you can think about the data in the enterprise, graphs provide this flexible foundation where you can put a variety of elements as nodes, and you can assign a different content to these nodes, and you can do that in a very flexible way. And also you can build connections between the nodes. You can do this dynamically, and you can grow your enterprise metadata system as you learn more about your enterprise, as you onboard a variety of data sources. And this is actually very important because it provides you with a terrific opportunity to start small and then grow your system, expand it over the different parts of your enterprise, and also include possible adjacencies with possibly different organizational structure. In addition to that, we have realized that by combining these data sources, you actually have ability to enrich the data that exists in one node. So you essentially are able to get a curated union of data around a certain element that is coming from a variety of ecosystems. And because people tend to think around their narrow verticals, you're actually providing a very useful insight by combining this. And then finally, the last thought is the effectiveness of graphs for exposing information. We have seen that there are visual representations of graphs that enable one to graphically explore the relationships, which is very powerful. And we have seen from Deepak's presentation, exposing this data in the UI and exposing it so that a variety of applications can easily consume it is also very important. And we have seen GraphQL as a very nice match to expose this final graph data model to external clients. Looking at the UI side, a variety of libraries, both in React and Angular and other frameworks, natively consume GraphQL data. So there is a very easy way to bridge our graphs on the backend to what the users are seeing in front. And with that, I will have Deepak talk to you about the future.
Thank you, Vladimir. So what's next? We do realize that all of us here, or most companies, are already actively working on technical catalog, classifying the data, and also making sure identity and access is a part of daily life. It's not an afterthought. And there are also a lot of companies and organizations who have taken people, geographies, hierarchies into the concept of metadata. So all these are different aspects that we are looking at are kind of defined as metadata already in today's world. But connecting it further is very critical. When we talk about artifacts, operational metadata, social metadata, which is evolving to become more important, it's basically seen as a technical metadata these days. Connecting all these dots along with our technical metadata, which we have already solved in few ways, is very important for us to building this deep interconnected graph of enterprise metadata. But when you start thinking about these aspects and putting together an architecture, this is where the foundational capabilities become very important. As we connect all these millions of nodes and edges, now looking at it purely from a technical perspective, how do we scale this system? Making sure the system is highly available, reliable, and also operable on a long-term perspective, or serious thought process coming into mind when we think about connecting all these at scale. And as you can see here, we are building this massive metadata of all the operational aspects in a company, which means that's a single vulnerable place which can expose large security issues. So the notion of multi-tenancy, making sure certain parts of the graphs can be exposed for certain personas and certain applications can build on the graph, is very important. So data security and multi-tenancy is going to be a very important aspect once we have dealt with the scale. And as we do all of this, as Vladimir nicely summarized, we have all these great front-end frameworks, React, Angular, and so on. We need to make sure that they can all work cohesively with our graph. Access simplification is very important. This is where GraphQL combination with Neo4j will really be playing an important part. And as we do all of this, we do need to realize the potential of Graph and Neo4j, the out-of-the-box capabilities that it offers. So we have to start in parallel deriving insights by running graph algorithms, ML algorithms on top of it to make sure that we are drawing intangible insights that are usually not easily seeable when we look at the graph. So these are going to be some of the aspects in terms of connecting all the data together while continuing to focus on the foundational capabilities. With that being said, I would hand over to Vladimir for the closing comments. Over to you, Vladimir.
Thank you. So here we are at the end of our presentation, but this should be the beginning of our conversation on a graph of enterprise metadata. We have prepared some code for you, which is in the GitHub. You can check it out and play with it with your database. And also we have opened the GitHub channel, so join in and ask questions and join the conversation. So thank you very much and good luck with your graphs.
Thank you, everyone.